into hypothesis testing. It's a recap of what I forgot to start the stream. All right. So this is what the real science is all about. When we take a look at the statistic, there is the one that it's currently ruling the world, right? Because it was provided in a study that was non-biased and whatever. So this is not giving me the one example what happened to your neighbor, or one example what happened to someone you know, right? These are the studies that contain thousands and thousands of individuals across all walks or whatever, right? So now, in order for us to do the hypothesis testing, and in order for us to actually take down some of these statistics that are known and established, we do something that's called hypothesis testing. So first we learn what is the null hypothesis. So the null hypothesis is a hypothesis to be tested. So hypothesis to be tested, and the symbol for that one is H naught, H with a little 0 in a subscript. Alternative hypothesis. A hypothesis to be considered as the alternative to the null hypothesis. So this is a hypothesis to be considered as an alternative to the null. When I write H, Y, P, is just hypothesis. Hypothesis test. Oh yes, it's ha. Alternative hypothesis, ha. It just stands for alternative. And the hypothesis, the problem in hypothesis test is to decide whether the null hypothesis should be rejected in favor of alternative hypothesis. So, hypothesis test is the problem. In a hypothesis test, is to decide whether the null hypothesis should be rejected in favor of the alternative hypothesis. Okay, so generally, I said something ridiculous, and you all know it's wrong. I said the mean weight of all Americans is 700 pounds, right? That's clearly wrong. So if the null hypothesis is that the mean of all Americans is 700 pounds, then you better challenge that with some data, right? Clearly, you're going to have a sizable sample. Sizable sample. I mean, you're going to have a large sample. So, when you go and make some kind of, you look at some kind of a mean, which is a statistic, right? You want to say that that mean is going to be different than the mean that you are proposing, and it's different in few different ways. So let's take a look at this. So mu is population mean. We know that from our previous life. And mu 0 is a specified value of the mean of the population mean. So there are three hypothesis tests that we are interested in. One that says that the mean you're proposing is different than the mean that it's established. I'll just put in the parenthesis two-tailed. And two-tailed test, number one. Number two, the mean you are proposing is smaller than the one established. Left tail test. And number three, the mean you are proposing is larger. Sometimes you don't know. Sometimes, right, you do. So we'll see. So this is right-tailed. Right-tailed test. All right, so there is a well-established, let's say, population mean for something. Whatever, pick whatever. There are three possibilities to challenge that established mean. One is just to say, you're wrong, right? You're challenging the mean by saying it's wrong. You don't know if it's smaller or larger. It's just wrong, and that's it. The other two are more specific. The mean that you are proposing is going to be smaller than the one that is established, and the mean that, and the other one is that the mean will be larger than that it's established. And we are going to run a calculation and simply say, okay, that's correct. Or so we reject the old one in favor of new one, or we keep the old one. So those are the conclusions. Those are the conclusions of the calculation eventually. So we either reject old one, we either reject null mu in favor of alternative mu, or we keep the null mu. Null mu is mu 0. So those are the conclusions. And now with this, there are possibilities to make errors, which is, if you follow the media, it's the whole thing is just full of these types of errors. And if you know enough stats, you can pinpoint them very easily. So this is true, this is false, and this is do not reject, and this is reject. You're rejecting null hypotheses. So so if you do the hypothesis testing and you came up with the conclusion just want to see what's the best way to approach this chart. So you can make two types of error. For instance, let me give you an example of a criminal in a court. We all know that there is a trial. Trial can be taken in this context as hypothesis testing. So now, the person who's accused of a crime is either truly guilty or truly not guilty. There is no somewhat guilty. So if there was a murder and a person is dead, the person on trial is either a killer or is not a killer, because maybe it's someone else. Maybe this person is framed or just been at the wrong spot at the wrong time, right? So the person on trial for murder is either 100% guilty or 0% guilty. There is no 13% guilty. All right. So just take as that situation of absolutes. So now, if you imprison someone who's guilty, you are making an error. If you imprison someone who's if you imprison someone who's guilty, you are doing the right decision. If you let go the person who's guilty, you are making an error. If you imprison someone who's not guilty, you are making an error. If you are not imprisoning someone who's not guilty, it's correct decision. Does it make sense? So there are four possibilities, right? In this case, there was a murder, someone stands trial. That person is truly guilty or not guilty. There are four possibilities. If the person is guilty and it goes to prison, correct decision. If the person is not guilty and doesn't go to prison, correct decision. But in the other two cases, the court is wrong either way. Not guilty person going to prison, and we know of cases, or a guilty person not going to prison, again, because of evidence manipulation or whatever, right? The reason the trial had to be dropped. So this is the same thing that we are going to have for hypothesis testing. If the challenge was true, right? Or challenge was right. So you gave your version of the mean, and it works out that your version of the mean is better, and you do not change the other one, it's an error. If your version is not good, but you still use it to change it, it's still not good. And then you have the two correct decisions. Your mean is better, you change it, great. And your mean is not better, don't change it, right? So those are the two good decisions. So in this chart is just showing these types, and we call these type 1 and type 2 error. So type 1 goes here, and type 2 goes here, and this is correct decision, and this is correct decision. So again, if you are struggling with a concept, just think of the trial, and there is a murder, and it's either guilty or not guilty, and then either let go or accused if the person was or was not at fault, and so on. So type 1 error, rejecting the null hypothesis when in fact true. Type 1 error, rejecting null hypothesis when, no coughing, true. Type 2 error, is not rejecting the null hypothesis when false. You eat chips, M&M stuff, right? They have, so the company prints on the packet how many grams of food you get in that bag. There is a machine that puts the stuff in a bag and seals the bag. So machine can malfunction. You can have half of the bag content inside. This is why we have to have quality control. So they would open random bags and make sure that the content of the bag is proper, right? Now,